Right. Hello, everyone. Thanks for joining the GeoBits webinar, the third webinar of the year 2024. We thank you for taking your time to join us and to listen to what we have for you. Before we go into the GeoBits webinar, just want to briefly introduce GeoBits and what we do. Right. So GeoBits, we act as a DBA partner for companies. We help companies to monitor and improve the performance of the database. And we are the partners of Microsoft in the data platform. And recently, we are also partnered with MongoDB on the data platform as well. So any form of database, be it MSSQL, MySQL, Postgres, MongoDB, be it on cloud or on-prem, we help you with all the service-related aspect of the database, in performance tuning to managing the entire database. Our engineers will be there 24/7 on the clock to help you on the same. So these are the few expertise and certifications that we hold. So in case you have any requirements on the database side, you can always reach out to GeoBits for the same as well. So our webinar for today is titled Unifying Data Landscape, Navigating MongoDB Data Federation Frontier. And it is going to be done by Sriram. Just to introduce Sriram briefly. So Sriram is our data engineer in GeoBits. And the thing I like about Sriram is he's a quick learner. He has completed his certifications MongoDB. And today he's going to speak on important topic in MongoDB. And I hope and wish all the very best to Sriram for today's webinar. And again, the title is titled Unifying Data Landscapes, Navigating MongoDB's Data Federation Frontier. Over to you, Sriram. All the best.
Yeah, thank you, Joel. Thank you for introducing me. So we will deep dive into this webinar. So let me share my screen. Yeah. So the today's webinar's topic is about unifying data landscapes, navigating MongoDB's data federation frontier. So we will walk through into this webinar. So yeah. So this is the agenda of this webinar. So we will first quickly overview about what is MongoDB and what is MongoDB Atlas, and then we will briefly discuss about what is data federation and its architecture and how it works. After discussing about these topics, we will go back into the use cases, features, and limitations, and we will discuss about how it works under the hood with a demo. So let's go into the first title, which is what is MongoDB? Actually, MongoDB is a non-relational database system that can be used to store data in the form of a document structure, which is not a authentic way of storing the data, which is usually we stored in the form of rows and columns, which is another tables in the relational database format. This is a NoSQL format, which means there won't be no SQL. Instead, we're using other than the SQL format like documents. In the documents means what in the sense is it's a key value for every key that will be associated with a value, so that we can easily correlate it with the rows and columns as key and values. So documents is the basic unit of the data which is stored in the MongoDB. Upon the level of the document, we have collections of documents, which is called as collection, and the collection of collections, which will be resided into a single database. So the layer will goes like this. Let me show. Yeah. So the layer will goes like this: a document, a database, which will have several several collections, and within a single collection, we will have several databases, and several documents, and this document will contain the structure of data, which is in a schema flexible. It's not a schema less; it is a schema flexible. What is the difference between a schema and schema flexible means? In a relational database management system, we use schema, which is fixed, and we have to enter the particular what we have the structured as a schema. We should have to enter. But in a schema flexible, we can enter what we have the flexibility to make changes of our schema. So this is how the MongoDB, the NoSQL databases have been differ from the RDBMS. And MongoDB is one of the popular databases in NoSQL databases. So many of the companies have been acquired MongoDB as their preferred choices for data storage. So this is the quick overview about MongoDB. Now we can dive into the MongoDB Atlas. What does Atlas mean? Atlas is the product of MongoDB, which is the main product. What is means? It is the database as a service to the business. Like what is the need for the Atlas is, if I am having an on-prem servers, we can go totally fine. We can install our MongoDB in our server and we can work with it fine. But if someone has no knowledge about how to manage the machines, they can go with the Atlas clusters. They can purchase the whatever the needs for them, and Atlas will provide as a database as a service which is hosted in the cloud. So our entire database will be hosted in the hosted in the cloud based on the based on nodes. It will be categorized as shared, serverless, and dedicated servers. And according to the workload, the prices of this categorization will differ. So here in this topic, Atlas going to be very helpful for us to illustrate the purpose of how the data federation works in MongoDB. So that's why I have put it in what is I just wanted to mention what is a MongoDB Atlas to that. So with all that further ado, we can dive into the real main part of the webinar, which is what is a data federation? Like we have a question we have a multiple databases. We have which for a long for a big enterprise or company, we have multiple sources of data. We have been hosted in several platforms like in Atlas cluster or in AWS or in some other cloud platforms. So we have to analyze the data like different sources of the data into a single source so that we can able to handle the data for an analytical purpose. This is the part of a data engineering. Like we put all the data sources into a single place, and from that we can able to analyze the data. So that's what the data federation is about to do. So I'll read about things. Data federation is a technology that allows users to access data stored in multiple sources as if it were stored in single database. This technology enables users to query data from multiple sources, join data from multiple sources, and replicate data across database. So what we are trying to say is the multiple sources of the data have been combined into a single source. Then we can use it for the analytical purpose. So the coming next slide will describe how it works. Yeah, this is the architecture of the data federation. Like we can see the Atlas data federation is the central part, but we can get multiple sources of data. This is the Atlas cluster itself. We can get data from multiple sources of multiple clusters, or we can get from the HTTP requests from APIs, or we can simply get from any cloud services like AWS, S3 buckets, or GCP, Azure Block, etc. And the other databases as well, like Redis, Postgres, on whatever the databases, data sources we can get for the Atlas data federation. So once we get the sources, we can put it in the Atlas data federation. From the data federation point of view, we can use it for the report stats for analytical purpose. So this is what the basic architecture of the data federation will go from. And the next slide will describe about how it works under the hood. Yeah. So you can, as mentioned in the previous slide, we can get the sources of data from Atlas cluster, Atlas data lake, or AWS S3 buckets. So we have multiple sources of data, and what the data federation process will start from here. What it's going to do is we have to combine all the data sources as in a single virtual database, which is none other we're going to host it in the same Atlas cluster. So in the virtual database, the federated database instance will create a virtual collections. The collections will be separated based on the multiple data we have been combined. So that's how it will start. It will a virtual database, and inside the virtual database, we will see virtual collections. And once the federated database instance is over, we can get into the pipeline section. In the pipeline section, what we're going to do is we have to create several aggregation steps to get the data, to get transform it and combine it, and just manipulate it for our analytical field. So this aggregation pipeline we have to build as a code for as a problem probably which is in the JSON format. We have to develop it, and whether the aggregation pipeline we have been developed put aside, we can able to use the out operator to get the output of the data into a Atlas cluster, again another Atlas cluster or a data lake or another AWS cluster. We can source that data, like point out the data to another. So this goes like this. We'll get multiple sources of data, and what is the data federated database instance will do is it will go into the virtual database. It will create a virtual database based on the federated database instance, and then the virtual database will create the virtual collections based on our data. Once the data source have been stored in the virtual database, it's all together. We can able to get the aggregation pipe. We can able to build the pipelines for delivering the query. And then the last part is we can get output, or we can get the federated query, so that we can one we can get stored in the AWS bucket or AWS S3 bucket or Atlas clusters or in any other form, or we can directly show for a small for simple time, similar time, we can get through the federated query. We can say it is a MongoDB query language, MQL, for this purpose. If we take out this entire data federation process, we have to manually write the ATL code for we have to get multiple sources of data, and have to create a pipeline by ourselves, put a lot of codes together. This is this is the part which normally data engineering work. Apart from that, it gives a quick, much simpler expression for how we can deliver the federated data as soon as possible, instead of writing multiple lines of code. So this is very handy at times. So this is how the data federation works under the hood. So we will go through a use case. Yeah. So we have now covered what is the data federation architecture and how it works. And now we can go with the use cases, like where are we gonna use when we gonna need this data federation. So this comes into the play of use cases. The data engineering, the front end most part of data federation is we're gonna use this in the data engineering part. Like as I mentioned earlier, if we want to replace the data engineering, the old data engineering process, ETL process at the time, which is very helpful for using this approach, data federation approach. Other than we can usually manually write multiple lines of code, and we have to create row of pipelines. It's also a good implementation, but it's also another source we can get quick data, which is inbuilt in the article. So that's one case which is in data engineering, and another is data reshaping and remodeling. So let's say we have our schema which is across different databases have been the data source which is a different format, and we want to make the analytical format which is in the parakit, which is a parakit file format, which is very efficient for using the analytical purpose. So if all our data sources in the original database format, but we want for analytical purpose, we want a different format, means we can go for the .parakit file format, which is easily be derivable from the data federation process. So that we will look into that. and data tiering and archival. For example, if we want multiple, as I said, multiple sources of data, but we want to compress the log, the for every 30 days we have to compress the data and put it in a storage like AWS S3 bucket. So what we can do is we can connect the multiple sources as a single source in the federated database, that virtual database. From the virtual database, we can get into the we can point out to the AWS S3 bucket or another cluster to store the compressed version of the data for every 30 days. So by this way, our original databases, which is connected to the application, will be much more faster and efficient to deliver the data sources will be quick. So this is the way that we can do for data tiering and archival. So these are the use cases that we're gonna implement for the that needs data federation. So next we will go to a problem statement. Before coming on to the problem statement, I will explain the further slide. Yeah. So we have mentioned about the use cases, and now we are going to the features. Like as I mentioned earlier, we can get for the analytical purpose. We may need some other formats of data like JSON, BSON, CSV, or in Parakeet for analytical purpose. Without further time complexity or space complexity, we will get the data format and we'll get the data in a separate format that we need for analytical purpose. So again, that we get for a federated query. By running a single query, we can able to get the access the data from multiple sources of data, which is the added advantages for this data federation that we consider. For the queries for on-demand means the queries that we perform based on the queries we will get be charged. So there is no particular fixation charge for the from the Atlas side. So this much amount of query, this much amount of price you have to be done. So we have to pay for the queries that have been run for the amount of data we have been pulled from the query. So that one, and we will go for the powerful aggregations within the MongoDB built-in aggregation tools. We can easily get the pipelines be done and to process the data in the from the data federation. And another thing is a serverless, which means that we can store in a dedicated. We don't need a dedicated server to be store this data federation and federated database. We need a simple what we can where we can store is we can simply store in the in the database where we hosted in the Atlas cluster, where we can already hosted the Atlas cluster. So that is completely serverless at some point, and it fully integrated with Atlas means we don't have to worry about anything that we don't have to maintain the machine that we have used for the federated databases. It will all will be look under with Atlas. We have just monitoring the purpose. That's all. So this is about the main key features about using the data federation. And talking about the features, we will have some several limitations. Like we cannot able to create indexes for the data we have been stored in the federated data. Like like we normally create indexes for the slow running queries in the MongoDB database. We cannot directly create indexes for the queries. And authentication methods will be the SCRAM, X.505 certificate, OADC, and the AWS IAM. Apart from the other authentications won't be work. So within this authentications only we have to be work on. And monitoring federated database with Atlas monitoring tools. We can only be monitor the database instances of a federated database with only using the Atlas tools on itself. We cannot able to use the third-party tools like Prometheus or any other third-party monitoring tools. We cannot able to monitor unlike other open source databases. But we can. But Atlas monitoring tools is pretty much itself enough. So creating a federated database instance with S3 buckets for more than one AWS account. For instance, we are creating S3 bucket means we cannot able to create for more than one AWS account. That is considered to be a downfall of this data federation within the Atlas. And querying documents larger than 16 MB, we cannot able to query the documents which exceeds the limit of 16 MB. So which is a very downfall of the data federation. So with that, is the conclusion. But before going into the ending the conclusion, we will say about how the problem, see about the demo purpose. For before going into the demo purpose, I just want to know, I just wanted to state a problem. Like we have two collections, like theaters and restaurant in separate clusters, but we want to access the separate clusters into a single data source so that we can get a query, so that we can get analyze from the that single source with the pin code. Like for this pin code, how many restaurants and theaters have been there, and we want their count, and we have to list them. So this is the problem statement we want, and for that we have to work. And this problem statement will be achieved by can be solved by using the data federation using the Atlas. So let's start. Let's start with the demo. Yeah. Uh, yeah. So to explain the demo, I just having already an instance in the Atlas cluster, which is project 0. I have already named it. So you need a project. For our assumption, we don't have a M10 cluster because we need to pay for the M10 cluster. So for our assumption, let's consider we have what does this means? For M10, for two M10 clusters, we can able to do the data aggregation process. Sorry, data federation process. The two clusters have been hosted in multiple, in different sections. Then we will go. Yeah, this is my overview of my database deployment. And for example, I'm having a sample data. Yeah. I'm having some multiple collections in it. Yeah, multiple databases in it. And inside that, I have collections and documents is all SSL. Okay. As I said in the problem statement, like we need to get the data of theaters and restaurants, which is hosted in different clusters. One is in AWS, one is in GCP. But we want this is our assumption. But here we are in the demo we'll having hosted in the same cluster itself, but it is that to be in a different database. In MongoDB, there is nothing we can be able to do, like different databases we cannot able to access in the single source. From that we cannot able to aggregate the data. So this is an comprehensive example for that. But let's assume that our database instance are in different cloud hosts. One is in AWS and in some other region, let's say, which is in Asia, and one in GCP, which is in North America. So we have hosted our databases clusters in different area region. So and that we gonna federate the data into a single database, and then in that single database we gonna get the query, run a query and get the analytical part. So in order to go to the data federation, we have go in the services part. We can go to the data federation. Yeah. For now, I don't have any the data federation databases. So I gonna create a new one. So in this we have a multiple things. For example, I have previously mentioned like we can able to connect our AWS S3 bucket as well, or a API or a REST API or a RESTful APIs to connect with the data from the APIs, or we can simply connect with the multiple sources of clusters in the Atlas itself. So we gonna do nothing in the support section, but we're gonna set up manually. Yeah. I'm gonna set the part for AWS itself, and then I'm gonna give the name as theaters and restaurants. Give the name as theaters and restaurants. It will continue. Yeah. In this section, it will ask for a data source. So we have to add the data source. So we will go to the here. Yeah, I mentioned last. We can add the S3 bucket or as a blob storage or MongoDB access cluster or even a HTTPS file. So here I'm going to select Atlas cluster. So in that cluster, I'm already having one demo cluster. For one project, we can create multiple data federation databases, but within a single project, only we can able to do the Atlas one cluster, one free cluster. We cannot able to do multiple clusters. For a multiple cluster, we have to go beyond the M10 clusters, which is payable. So we're gonna have yeah in this sample mflix data in the sample mflix database. Sorry, this is, yeah. In this database, I'm gonna get this theaters collections. And in sample restaurants database, I'm going to get the restaurants. So in theaters and restaurants, we will have pin codes which is associated with each of the document. By filtering out the pin codes, in what pin codes, how many theaters and how many restaurants are going to be there. This is the main PowerPoint we're going to cover for this data. Once we have selected our data, we can go to click the next. Yeah. Now we can able to see that the two collections have been stored in this place. So we'll simply gonna drag and drop this here. So this is as we can mention, like in the PPT, there is a visual database and a virtual collection. Like that we have mentioned, like in the federated database instance, we can have a virtual database. Inside the virtual database, we have the virtual collections. So this is the virtual database, and inside the virtual database 0, we have virtual collection 0, and inside the virtual collection we have the clustered data, so that we have stored in. Once we have the stored in that area, we can simply give create. If we don't put our IP into the connection part, we cannot able to access. So before connecting to that access, make sure that you are provided your current IP to access this. So now we have created the theaters and restaurants data federation part, data federation database. Now we have to connect to our database. So federated database. So how we going to do this? So we have multiple options here. We can go with MongoDB shell or our applications, or simply many options are available. In this purpose, I'm gonna demonstrate about we can have MongoDB's Compass UI, shell, MongoDB for Atlas SQL. But in this demo, I'm gonna explain about how the MongoDB for VS Code will help to aggregate it. So let's go into the MongoDB. I have already installed the VS Code, and I have the plugin for MongoDB plugin, and now I just simply need this connection string. So I'm going to get the connection string. Go to my Visual Studio. In the Visual Studio code, once you enter into that, we can go to the command palette like Ctrl+++P. then we'll click, and that we can see that MongoDB connect with the connection. Yeah, so I'm going to click onto the connection. So yeah. Once again. Yeah. Once we have entered our connection string, it will be asked like this. Okay, we can.
Sriram, I think on mute.
Oh yeah, sorry. Yeah. Yeah, I'll come to the. Yeah, I'll come from first. Like yeah. In the MongoDB connection palette, we gave the. This is a MongoDB extension with the Visual Studio Code. So once the Visual Studio Code has been have the MongoDB connection extension, we can able to connect with the connection string as well. We can get the connection string from that place, and we can simply paste it over here. Like they gave this, and it asks for the connection string. Once you have connected the put the connection string, and the MongoDB will be connected. Yeah. Once the MongoDB has been connected, we can able to see our connection with this MongoDB icon, and we have seen the connections. What are the connections have been done previously? These are the previous question which is not able to see. Yeah. Now federated database have been successfully connected. So here we can able to see the documents. There are 27,000 documents for the theaters and the restaurants. You can able to see the schemas, indexes as well. Okay. We have created a playground, and in MongoDB tutorial, one code is there, like what is our exact problem statement I have been dealing with. In that we have this data pipeline code. We can simply copy this and paste all this. So we can now we can able to see that in the first stages of the aggregation. In in the first stages of the aggregation, we can able to see that we get the collections of a restaurant and the theaters based on their pin code, like address.zip code and the locations.address.zip code. So in that we can combine them together. If a zip code is if it's not available, we can add the zip code as a populating of the data. This is the first stage of the pipeline. In the second stage, what we can able to do is we have to group them together. We have the different the database is different. One is in another databases and another is another database and another collection. So we're gonna group them together in this stage of the pipeline. Once the grouping process have been completed, we can able to see the theaters and restaurants section, which we grouped together, and this is the part where we can able to get the total. Like every part will be counted as someone, and for every run, the sum will be the total will be get increased. And once the stage 2 will be will get executed, that stage 3 will show the total number of theaters and restaurants which is presented in the zip code. So we can get the zip code as the primary key as the ID, and the total section means total number of theaters plus number of restaurants as total, and we'll get the sizes of the theaters and restaurants. This is number of theaters and number of restaurants. Once we have done this, it will be stored as a document. And what we have to do is finally we have to sort the current document in the descending order, so we can able to see from the descending order wise. So this is the entire pipeline. So once we get hits run, we can able to see what we have run, what we can run in the process, like how we can get the data from the different sources. Like as I said, like one is in AWS, one is in GCP, which is in different clusters, and get the different clusters into a single data source that as a federated database. And then the federated database we can able to query, which is this M query, which is a federated query. This is the federated query. Once the federated query has been before running that, we have to change the data. Okay, this is yeah. Now we can able to see the okay. This is a different place where we have running this thing. Yeah, this would work. Okay. I have changed the name of the database, so I have to change here as well. By this time it's not work. Yeah. Yeah, some issues there in this running code. Just let me debug this.
I think you are on mute.
No, 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 I'm just Yeah. Let's create another one. Yeah. Okay, I'm gonna add this. Okay. This will database 0. Again. Okay. But we can. Yeah. Now we have created a icon for this. Comment it out and go for the code that we want to do. Let's paste it. So as I mentioned earlier, this is the pipeline, aggregation pipeline. There are 4 stages in it. Should be, yeah. No, it should have to be. Yeah. Some errors in previous, so that's why I decided out the building game. Now we can able to see this is the pin code. This is the pin code of yeah, this is the pin code of the area, and in that pin code we have total number of restaurants and theaters. Total this is total number of restaurants plus total number of theaters is 688, and along that we have 2 theaters and 686 restaurants. Likewise, it have been sorted in the descending order. So this is the example evidence. We can able to clearly see that there are 2 different data, different clustered collections have been sourced into a single database, and that from the database we can able to run the aggregation, and then we can able to get a data which is kind of similar, that both the collections have been presented in a single database, but actually they are separated in different regions, but we can able to get the data as a single source. So this is the power of the Atlas aggregation, Atlas data federation. So this is the demo that explains how it works. So again, I'll explain what it have been done. So we go to my database. let's see how the browse the collections. First, I have take the sample restaurants. In that, we can able to see there are multiple restaurants. Like we can able to see multiple restaurants out there. In that, we have address, and in that address, in this document, we have the pin, and based on that, we can able to get how many restaurants have been in that single pin code. So this is for restaurants, and again we have another database, which is sample flip mix, and in that we have another collection theaters, and we can able to see the theaters having the location object. In the location object we have address. Yeah, in the zip code we have some amount of zip codes for every theater. Based on the data, what we have done is pull the pin code of both of the collections and group them together. Based on the pin code, how many databases have been in there, how many theaters and how many restaurants have been in there, we have sorted out in a aggregation. So for our assumption, this sample MFLIX and the sample restaurants have been hosted in a different clusters. For analytical purpose, we need to know how many restaurants and how many theaters. But by using the data federation concept, we can create a virtual database, which is a federated database, and in that we have created federated virtual collections. And inside the virtual collections, we can able to inquiry what is how can we aggregate those two clustered data into a single one. So from that we can able to get this data. This is the output of that data, output of the thing that we wanted, and we can able to change this into another format, like as I mentioned, packet format or CSV, or we can store this data as in AWS S3 buckets, or we can simply connect one S3 bucket and one Atlas cluster and combine those two into a single federated database, and from that we can able to do the analytical purpose. Or we can or I have mentioned in the previous, like we can able to do the data archival process by using this. We have multiple sources of Atlas clusters, and in that we can, from that we have to combine those into a single one, and based on the time, like let's say 30 days, we can able to compress the data and can store the data in the S3. So this is all about how the data federation in it is working. And going back to the presentation. So we have mentioned the limitations, and this is the conclusion, like about how we have effortlessly done the process without doing any ETL process. This is actually an ETL, but in overlapping with the data engineering, this is a more efficient to do, which is a great feature that has been built in the Atlas itself. So this is how the MongoDB Atlas Federation works. So that's all.
Yes, Sriram. So thank you for that wonderful session on MongoDB Federation, highlighting the benefits, this architecture, and how we can use it, and also providing a live demo of how it actually works. Thank you so much for that session. A quick, short time to have questions. We are almost done with our time. Any quick questions that we have? Anyone from the team? Okay, so if there aren't any questions, we would like to wind up the session now. Thank you everyone for joining, and always keep a lookout for these more upcoming webinars in the future as well. We'll be posting the highlights and on the YouTube of this current session also on our YouTube channel, and also follow us on LinkedIn so that you will be updated on the new webinars that will be coming up in the future, so that you can also join and grasp more insight on different databases and applications, the services which it offers. Thank you, everyone, and have a great rest of the day. Take care.
Yeah, thank you, Dhruv.